A fast-moving object the size of Manhattan is hurtling towards our solar system, and it will make its closest pass to Earth.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live.
The moment astronomers confirmed that an immense object had slipped across the outer rim of our solar system, attention across observatories and research centers tightened on its path. What startled researchers most was not simply its enormous mass or strange composition, but the trajectory that brought it directly towards 3I/Atlas, the interstellar visitor already threading a delicate path through the solar system. The scene suddenly resembled a cosmic chessboard, one massive and unknown player moving into position near a traveler that had itself already sparked scientific fascination. Before we start, smash the like and subscribe buttons for more updates. The object's discovery unfolded gradually but with mounting urgency. At first, faint disturbances in the alignment of known celestial bodies suggested something massive was exerting gravitational pressure in regions where no planets, dwarf planets, or recognized comets were supposed to be. Advanced instruments at long-range telescopes picked up irregularities in the orbit of distant icy bodies. Soon, the faint shimmer of reflected sunlight betrayed the newcomer, a ghostly glint on a trajectory unlike that of any comet or asteroid cataloged. Its apparent bulk dwarfed conventional comets, stretching across kilometers in breadth, and it carried a density profile suggesting a far stranger origin than ordinary chunks of ice and rock. As astronomers tracked its motion, it became clear that its target seemed fixed: 3I/Atlas. That object, known as the third interstellar body identified passing through our solar system after the renowned Oumuamua and 2I/Borisov, had already sparked debates over whether it carried volatile chemistry from another star system. Now, the arrival of a massive, unidentified companion hurtling toward it deepened the intrigue. Was this a coincidence of orbital mechanics? A random crossing in the crowded lanes of cosmic drift? Or did the trajectories hint at some deeper connection, a pairing flung across interstellar space together? The scale of the giant object immediately shifted the tone of scientific discussion. Unlike smaller interstellar passers-by, this new arrival could not be dismissed as another wandering stone or comet. Its gravitational influence alone created ripples measurable across millions of kilometers. The immense body altered smaller orbits around it, tugging at asteroids and shifting dust patterns in the Kuiper Belt. For planetary scientists, the arrival promised a laboratory in motion, a chance to observe interactions on a scale rarely witnessed so close to home. The fact that it was converging on 3I/Atlas made the opportunity all the richer. Two interstellar travelers potentially colliding or dancing around each other in our own celestial neighborhood. The implications reached beyond planetary science. Observatories scrambled to recalibrate sensors, hunting for emissions in radio, ultraviolet, and infrared bands. Was the object inert, a massive silent bulk drifting endlessly, or did it conceal processes that radiated energy? Initial readings hinted at a surface unlike that of known comets, less reflective than ice, darker than carbonaceous asteroids, absorbing light in ways that suggested exotic compounds. Some speculated it might be sheathed in materials altered by cosmic radiation during countless eons between the stars. Others wondered if it contained metals forged in the violent death throes of a long-gone star, carried as relics across gulfs of space. As models of its trajectory solidified, the sheer improbability of its path toward 3I/Atlas deepened. Celestial mechanics rarely gift such alignments, and yet here were two foreign visitors arriving in synchrony. The thought tantalized those who considered interstellar objects as messengers, fragments of other star systems carrying stories of their birth environments. If the gigantic object was truly related to Atlas, if the two had been companions flung free of some distant sun together, then scientists stood on the brink of uncovering a narrative stretching across light years. By comparing their compositions, their motions, and their behaviors under the influence of our star, new windows into the architecture of alien systems could open. The sheer size of the newcomer demanded comparisons with familiar solar system giants. Unlike dwarf planets such as Ceres or Eris, it seemed less spherical, its irregular silhouette suggesting a colossal shard rather than a rounded world. Yet its density implied compact matter, not the fragile ice mixes of typical comets. It may have once been part of a larger world, shattered in some interstellar catastrophe, then hurled outward at escape velocity. To trace such a journey was to speculate about supernova shocks, violent gravitational encounters with giant planets, or even interactions with passing stars that had nudged it into a lonely path through the void. Meanwhile, public fascination ignited. The idea of a colossal visitor threading into the solar system captured imaginations beyond the astronomical community. Media outlets spoke of a cosmic leviathan, though scientists remained careful to temper descriptions. Yet, even within their caution lay awe. Few events in recorded history had presented humanity with a natural experiment of this magnitude, a tangible piece of the galaxy wandering into reach. Each new data point added drama. Its rotation period, the faint jets of material suggesting partial activity, the strange electromagnetic disturbances accompanying its path. If it indeed intersected with 3I/Atlas, the interaction could range from a distant gravitational handshake to a full-on collision, depending on the subtleties of their orbits. A near miss would still offer extraordinary opportunities, as the two bodies might exchange material, tug each other's paths into new directions, and reveal much about their cores. A collision, while less likely, would unleash energies spectacular enough to be visible across much of the solar system, scattering fragments and dust that could be studied for years. Either way, the event promised revelations about the structure of interstellar matter, the chemistry of alien systems, and the physical processes of large-body interactions. Researchers emphasized the importance of rapid observation campaigns. Instruments across the globe and in orbit coordinated, much like during historic comet approaches, but on a scale magnified by the newcomer's mass. Proposals circulated for redirecting probes already in deep space to adjust their trajectories for a closer look. Even the possibility of using the outer planet's gravitational slingshots to accelerate future missions toward the object began to appear in planning discussions. The urgency stemmed from the fact that such events are fleeting. The visitor would not linger indefinitely. Like other interstellar passersby, it would continue on, exiting the solar system after its brief encounter. Missing the chance now would mean waiting centuries for another comparable alignment. Theories multiplied regarding the object's internal structure. Some researchers pointed to data suggesting metallic inclusions, raising the possibility that it was not purely natural rock and ice, but a fragment of a differentiated planetary core. If true, then the object was a relic of a once larger body that had undergone planetary formation processes similar to Earth's. Such a relic could hold the frozen magnetic history of a long-dead star system, preserved like a cosmic fossil. Others pushed even further, speculating whether its unnaturally direct path toward 3I/Atlas hinted at interactions beyond blind chance. Could the two objects have once been bound, a binary pair wandering together? Or was the alignment merely the product of human tendency to see patterns where chance rules supreme? Amidst the debates, one constant remained: the magnitude of the opportunity. With the gigantic object bearing down on Atlas, astronomers prepared to witness processes that had previously been left to computer simulations. The dust tails, shock fronts, and gravitational waves of two interstellar bodies brushing past each other could now be measured directly. Planetary defense specialists also watched carefully. While neither object posed a threat to Earth, their paths reminded humanity of the power of celestial mechanics. The gravitational ballet unfolding in deep space underscored how easily the fate of worlds could hinge on the passage of wandering giants. Beyond scientific implications lay the philosophical weight. To glimpse objects born in alien systems was already a rare privilege. To see them converge within our solar system was to witness a cosmic narrative too vast for ordinary human timelines. These were emissaries of the galaxy, carrying with them silent histories from billions of years and countless stellar generations. The gigantic object, with its dark, brooding mass, represented the unknown on a scale rarely so near. Atlas, smaller but equally mysterious, stood as a reminder that even our star's neighborhood is not immune to visitors from afar. Together, their encounter promised a drama etched in starlight. Every day brought refinements to models predicting the closeness of their approach. Minute calculations altered timelines, suggesting the convergence might occur nearer to the orbit of Jupiter or farther out among the Kuiper Belt objects. Each scenario carried different implications for observation. A rendezvous nearer the gas giants could allow instruments already in orbit around Jupiter or Saturn to participate. A meeting farther out would challenge technology but yield purer data, free from planetary interference. Either way, anticipation built, as if the solar system itself had become a theater for an interstellar play. The notion that two alien objects might meet within sight of human instruments blurred the lines between natural science and imagination. Writers and thinkers spoke of destiny, of cosmic threads drawing together. Scientists remained grounded, parsing data, but could not escape the sense of privilege in watching such a spectacle unfold. Generations of astronomers had studied their skies, but few had witnessed such a coincidence. The solar system becoming the crossroads of interstellar travelers. Even the silence of the objects contributed to the awe. Unlike spacecraft launched with deliberate intent, these masses drifted indifferent to observation. They bore no message carved by hands, no intention guiding their path, yet they carried within them records older than humanity itself. Spectroscopy promised to decode their chemistry, to reveal whether their molecules mirrored or diverged from those known on Earth. Perhaps amino acids lingered in their icy cracks, or perhaps they carried exotic compounds born under the glow of stars unlike our sun. Each answer would add to the story of how matter assembles, evolves, and travels across the galaxy. For now, the solar system holds its breath. The gigantic object advances relentlessly, its trajectory precise, its shadow lengthening across calculations. Atlas, already enigmatic, awaits its encounter. Between them lies the possibility of a celestial interaction that could rewrite understanding of interstellar migration and planetary origins. Humanity watches, instruments poised, imagination stretched, as the drama of two alien wanderers prepares to unfold under the gaze of our sun. The gigantic body continued its solemn march inward, passing thresholds of distance that previously seemed to insulate the solar system from such enormous wanderers. Astronomers cataloged each incremental shift in position with reverence, for every measurement peeled away another layer of uncertainty. By now, the object had developed a distinct profile across observatories, an elongated mass, irregular, scarred by what appeared to be ancient collisions. The faint halo of dust trailing it suggested activity, but not like the familiar comets whose frozen volatiles erupt spectacularly when warmed by the sun. This dust appeared heavier, more granular, clinging to the body's gravity rather than streaming away in neat jets. What puzzled scientists most was its rotational behavior. Unlike most natural bodies that spin at predictable rates, this newcomer's rotation wavered, sometimes accelerating, sometimes slowing, as though internal structures shifted mass unevenly. The fluctuations challenged the idea of a stable monolithic bulk. Instead, researchers proposed layered strata within, or even vast caverns that redistributed inertia as the body tumbled. The thought of hollow regions within such an interstellar behemoth ignited fascination. If voids existed, they might preserve pristine matter untouched since the dawn of its creation, sealed within an interstellar vault. Attention turned toward its approach vector. The line of entry cut through the solar system at an angle seldom seen in long-term orbits. This was not a body that belonged here. It bore the unmistakable signature of an outsider, its speed and direction inconsistent with anything native. Calculations revealed that millions of years ago, perhaps near another star, a violent force had cast it adrift. To reconstruct that origin was like reconstructing the genealogy of an orphan found on one's doorstep, yet the challenge invigorated planetary scientists. Star catalogs were scanned for potential candidates that could have birthed it, stellar nurseries and exploded suns that might explain the richness of its materials. Meanwhile, 3I/Atlas continued its solitary progress along its established path. Though smaller by comparison, its interstellar heritage already made it a jewel of study. With the newcomer pressing toward it, the possibility of shared origins became an irresistible hypothesis. Both objects, though separate in mass and appearance, might have been siblings long ago, part of a single system, perhaps fragments from the same catastrophic event. To imagine their reunion in our skies after drifting light years apart was to imagine the cosmos staging a grand reunion before human eyes. One key question dominated discourse. What would the solar system look like during their interaction? If they passed close enough, their mutual gravity could alter both paths dramatically. Atlas, already vulnerable to the sun's heat, could be torn by tidal stresses, its icy core venting spectacular plumes. The gigantic object, though sturdier, might also shed fragments, exposing inner material. Even if no collision occurred, the dance between them promised visual and scientific fireworks. Light scattering off debris fields, gravitational resonances echoing through smaller asteroids nearby, and sudden chemistry unleashed into space, all awaited capture by telescopes, satellites, and probes. Research organizations began pooling resources, setting aside rivalries in favor of coordinated monitoring. This was not a moment for fragmented observation, but for a collective effort that spanned continents. Data-sharing agreements flowed swiftly. Even nations typically guarded with information recognized the unparalleled value of the event. The international nature of the undertaking echoed humanity's shared position beneath the same sky. Instruments from Chile's deserts to Hawaii's volcanic peaks, from orbiting telescopes to Antarctic observatories, synchronized their eyes on the object. Beyond the purely scientific, cultural dimensions emerged. The appearance of a colossal interstellar body sparked age-old tendencies to ascribe meaning to celestial arrivals. Myths were revisited, comparisons drawn to comets once viewed as omens. Yet unlike ages past, when fear dominated, modern societies balanced awe with curiosity. Artists painted its imagined surfaces, filmmakers rendered speculative animations of its eventual meeting with Atlas, poets described its silence as the voice of deep time. Humanity, in all its expressions, grappled with the enormity of welcoming such a guest into the family of our solar neighborhood. Astrophysicists worked to refine models of the body's internal structure. One theory suggested that it might consist of a dense metallic heart wrapped in fractured silicate layers. Such a composition would not only explain its mass and irregular spin, but also hint at processes akin to planetary differentiation, implying that it once belonged to a larger world. If so, then the gigantic object was not just a rock, but a relic of planetary formation elsewhere, perhaps from a system whose architecture mirrored ours in surprising ways. Holding such evidence would allow humanity to test theories of planetary science beyond the solar system, offering parallels that otherwise could not be observed. Another school of thought proposed that the body was a primordial shard, a survivor from the earliest epochs of star formation. In this view, it was less a broken piece of a planet and more a preserved block of ancient matter, hardened before planets had coalesced. Its chemistry might then retain unaltered ratios of elements and isotopes, telling a story not just of one star system but of galactic history itself. The confrontation with Atlas might reveal which of these theories held truer, as the interaction could strip layers, expose interiors, and give scientists spectroscopic glimpses impossible from surface readings alone. As the object neared regions where sunlight grew stronger, its surface began to reveal new characteristics. Subtle outgassing occurred, but instead of the volatile ices that defined most comets, these emissions contained compounds rarely observed in solar system bodies. Strange hydrocarbons, metallic vapors, and possibly even complex molecules streamed faintly from cracks and fissures. The detection of these exotic signatures ignited speculation. Were these molecules products of alien chemistry shaped under a star of different temperature and composition? Did they represent entirely novel processes, hinting at forms of chemical complexity beyond Earth's experience? The practical challenges of observation multiplied. The sheer distance, even within the solar system, meant that instruments strained at their limits. Adaptive optics sharpened images, but only spacecraft could bring clarity. Proposals for rapid response missions flooded agencies. Could probes already outbound, perhaps those heading toward the outer planets, be adjusted to intercept? Engineers evaluated trajectories, fuel requirements, and communication timelines. The window was tight. Once the object passed, its speed would carry it irretrievably away. The prospect of a fleeting encounter spurred urgency unlike any previous mission. Philosophical debates flourished alongside technical ones. Some scholars saw in the event a reminder of humanity's smallness, that the universe occasionally reveals pieces of its vast machinery that dwarf our comprehension. Others emphasized the privilege of timing, that our species arose at precisely the moment when such spectacles could be observed. The cosmic object did not aim for Atlas in any intentional sense. Yet the convergence felt charged with significance, as though the galaxy itself conspired to deliver lessons in scale, origin, and interconnectedness. Public engagement deepened. Planetariums hosted nightly events, streaming live data as it arrived. Families gathered under domes to witness simulations of the paths, while children asked questions about alien worlds. What it would feel like to stand on such an object. What colors its sky might reveal. Teachers wove the story into classrooms, emphasizing both the thrill of discovery and the humility of being part of a cosmos so immense. For many, this became the first astronomical event they followed in real time, a generational moment of wonder akin to past moon landings or eclipses. As the days narrowed to weeks, predictions grew more precise. The massive body and Atlas would indeed converge within a margin that guaranteed mutual influence, though the exact distance remained contested. The possibility of a direct strike still lingered, slim but real, enough to fuel both caution and fascination. Models projected dazzling outcomes, luminous plumes visible even from Earth's night sky, trails of debris stretching across interplanetary space, gravitational tremors reshaping Atlas's path permanently. To imagine two alien travelers colliding in our skies was to imagine the cosmos staging a rare drama for human eyes. The role of gravity loomed large in discussions. While electromagnetic emissions revealed composition, gravity dictated destiny. Simulations of the gravitational interplay suggested that the larger body could capture Atlas temporarily, binding it into an unstable binary before flinging it free again. Such an event would be unprecedented in human observation, a binary system forming briefly within our solar system between two objects born far away. This possibility tantalized astrophysicists, for it would demonstrate dynamics otherwise relegated to theory. Meanwhile, questions of preservation arose. If fragments broke free during the encounter, could any be collected? Plans circulated for deploying capture nets or dust collectors aboard existing spacecraft. Even minuscule grains carried immeasurable scientific wealth, each particle a time capsule of interstellar history. Agencies debated the practicality of such missions, balancing risk and cost against potential returns. The race against time underscored the rarity of the opportunity. Miss it now, and another such chance might not appear for millennia. At the edge of speculation lay the idea of organic chemistry. Interstellar objects had previously revealed simple organics, but the sheer mass of this body suggested reservoirs capable of harboring more elaborate compounds. If complex molecules rode within, their encounter with sunlight and the pull of Atlas could release them in detectable quantities. Detecting such chemistry would not confirm life, but it would demonstrate that the building blocks of biology exist broadly in the galaxy. The meeting of these two objects might scatter seeds of chemistry across the solar system, reinforcing theories that life's ingredients travel freely between stars. The story of the gigantic object thus became more than astronomy. It became a meditation on interconnectedness. From the physics of orbital mechanics to the poetry of cosmic reunions, from the practicalities of spacecraft navigation to the speculative dreams of galactic genealogy, the event tied disciplines together. Scientists, philosophers, artists, and everyday observers shared in its unfolding. The object bore no intention, yet in its silent approach it bound together diverse strands of human thought, uniting curiosity across borders. As it pressed onward, the object began to interact subtly with the solar wind. Charged particles streamed around it, forming bow shocks and magnetic disturbances. Instruments detected fluctuations in plasma densities, ripple effects that painted the solar wind with new patterns. This added another layer of study, revealing how alien bodies behaved under the influence of our sun's invisible breath. Each new measurement expanded knowledge not only of the object itself, but also of the heliosphere, the protective bubble around our system. Weeks stretched into days, and the approach neared culmination. Atlas glimmered faintly in telescopes, a modest interstellar traveler already rich with stories, while the massive newcomer loomed like a shadow swallowing starlight. Predictions of their nearest approach filled journals and news feeds, each estimate slightly refining the expected spectacle. Would they brush past, exchanging only whispers of gravity? Would fragments collide, sparking visible flares? Or would the unimaginable occur, a full merger of two alien wanderers in our solar system sky? The anticipation itself carried weight. Humanity, for once, shared in collective observation not for fear, but for wonder. All eyes turned upward to watch the silent meeting of masses forged in alien forges, carried across light years, arriving by chance within sight of a young civilization. The solar system became not just a home, but a stage, upon which the galaxy briefly performed, and the gigantic object, with its immense mysterious bulk, pressed forward relentlessly, its fate entwined with Atlas, its secrets poised to spill into the instruments and imaginations of all who watched. The convergence of two interstellar wanderers in our solar system was not merely an astronomical curiosity, it was a rare alignment of scale, timing, and mystery. As the massive object bore down on 3I/Atlas, scientists began to detail aspects of the encounter that had not yet been emphasized. Central to their interest was the relative velocity at which the two would approach one another. Unlike encounters between familiar comets and asteroids that often unfold within predictable speed ranges, this meeting involved bodies with origins beyond the heliosphere. Their velocities were therefore extreme, shaped by ancient trajectories that carried them across the galaxy. Calculating the energy of their approach revealed magnitudes surpassing any event humans had directly observed in their skies. The speed alone promised a spectacle of physics. Should even fragments from the two make contact, the release of energy would far exceed typical impacts recorded in the solar system. Such a scenario could generate shock waves that cascaded outward, producing bursts of radiation and scattering matter in radiant arcs. For those watching from Earth, this would not resemble the quiet drift of comets, but the sudden violence of cosmic forces long hidden in the dark between stars. The possibility of luminous signatures visible across the solar system drove researchers to adjust instruments, preparing for flashes of ultraviolet and X-ray light that might accompany the event. Attention turned also to the magnetic properties of the giant intruder. Many interstellar bodies carry remnant magnetism from their parent systems, encoded within their metallic inclusions. If the object bore a strong magnetic field, its interaction with the solar wind and with Atlas could generate complex electromagnetic disturbances. Auroral phenomena might appear in miniature around the bodies, glowing veils of charged particles dancing across alien surfaces. Instruments designed to measure magnetic flux lined up their observations, eager to record whether this traveler bore a magnetic memory of the star system from which it came. Such data would give scientists the first chance to compare magnetized relics across multiple stellar environments. As the time of approach neared, researchers began to focus on the geometry of the event. Unlike past interstellar visitors, which largely bypassed our system at great distances, these two objects were set to pass in close proximity within a region accessible to both telescopes and, potentially, spacecraft sensors. The orientation of their orbits meant that Earth itself occupied a vantage point tilted at an angle, providing a wide view of the unfolding dynamics. This geometry promised clarity. Observers could track the leading and trailing edges of the objects without obstruction, measuring asymmetries that would reveal details of shape, spin, and outgassing. The prospect of capturing acoustic data, though unconventional in the vacuum of space, also entered scientific discussion. While sound cannot travel in emptiness, plasma waves created by the interaction of solar wind with massive objects produce oscillations detectable as electromagnetic voices. Specialized instruments could translate these plasma waves into audible frequencies, allowing humanity to hear the passage of the alien body. Engineers speculated that the meeting of Atlas and the giant intruder might yield a symphony of charged interactions, each frequency a coded signature of interstellar history. Curiosity deepened around the surface textures of the colossal visitor. High-resolution imagery, though grainy, suggested features unlike typical craters. Instead, its surface bore grooves and ridges aligned in patterns, as though stretched by immense forces. Some proposed tidal distortion during its ejection from its parent system. Others speculated that collisions with dense interstellar clouds might have scarred it over eons. These marks became the focus of geological speculation. If studied closely, they could reveal the environments the body had traversed on its million-year journey. To think of its surface as a diary, etched with encounters across vast distances, gave the object an almost narrative quality. The chemical composition of emitted gases demanded particular attention. Among the detected compounds was evidence of sulfur-bearing molecules rare in solar system comets. Such molecules suggested a history tied to volcanic activity or differentiation in a parent body rich in sulfur compounds. If accurate, this meant that the gigantic object once belonged to a system with volcanic processes, perhaps worlds similar to Io or early Earth. To study these emissions was to sample not just a fragment of rock, but a hint of alien planetary geology. The meeting with Atlas might amplify such emissions, creating plumes large enough for detailed spectroscopy. Simultaneously, planetary defense researchers scrutinized the encounter from another angle. Although the objects posed no direct threat to Earth, the demonstration of such trajectories underscored vulnerabilities. If a body of similar size and speed were ever to align with Earth, the consequences would be unthinkable. Thus, the event served as a natural simulation for defense models. Observing the gravitational influence of the giant intruder allowed scientists to refine predictions of how similar masses would behave near Earth, enhancing preparedness for hypothetical scenarios centuries hence. Cultural fascination deepened into ritualized observation. Across continents, communities organized sky-watching vigils, treating the event as a shared human milestone. In deserts, mountains, and city rooftops, people gathered to gaze upward, even though the objects themselves were too distant for naked eyes. What mattered was the participation, the acknowledgement that two ancient travelers were converging above. Artists incorporated real-time data into performances, using projected orbits and plasma signals as material for music, dance, and visual art. Humanity did not merely watch. It celebrated, embedding the event into collective memory before it had even finished. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on a gigantic object entering our solar system? We want to hear from you. Thank you for watching, and see you next time.